Okay, so this next part is really important to understand. It says not every quotient needs to be differentiated by the quotient rule. So the idea is if you see a fraction, that doesn't automatically mean you're going to be using the quotient rule. You need to think about that fraction first. Remember, if it's a single term, you can always separate and simplify first and then deal with the problem. Okay, so for instance, let's look at this first example right here. For A, it says find the derivative of y equals x squared plus 3x. There's a couple different ways that we could do this. For instance, what you could really look at this as 1/6 times x squared plus 3x. And so when we want to find the derivative of that, y prime, it's just a constant multiple. So that 1/6 stays out in front. We take the derivative of x squared, which is 2x to the first, or just 2x, plus 3 times the derivative of x, which is just 1. So when we do this, we would end up with 1/6 times 2x plus 3. We could either leave our answer like that, or we could actually multiply it out. In other words, do the 1/6 times the 2x and then the 1/6 times 3. If we did that, the 1/6 times the 2x, well, that would be 2/6, which is really 1/3 x, plus 3 times 1/6 is 1/2. So that'd be one version of it. I'm not going to lie, this version of it would have been perfectly fine as well. Or you see them write it in the book as 2x plus 3 all over 6. I don't care which one of those three versions you do it as, it's perfectly fine by me. I'll go ahead and do the 1/3 x plus 1/2. I don't know why. It's just because that's how I saw it personally. Any of those three answers I would have given full credit on the test. But notice we didn't have to do low d high minus high d low over what's below squared. There was no reason to do the quotient rule on that problem. Let's look at the next one, 5x to the fourth all over 8. Yes, technically that is a quotient, but like we saw in the previous chapter, or previous section, we could use this as a constant multiple. This is really 5/8 times x to the fourth. So finding the derivative with the quotient rule, low d high minus high d low over what's below squared, very difficult. Finding the derivative as a constant multiple, super, super easy. This is 5/8 times the derivative of x to the fourth. Well, x to the fourth would be 4x cubed using the power rule. Drop down the power of the power minus 1. Then we do a little bit of simplification. The 8 and the 4 would turn into a 1 and a 2 when we simplify. So it looks to me like we'd have 5/2 times x cubed. Again, you could write that as 5x cubed over 3 if you prefer. But that's how I'm going to leave my final answer, is 5/2 times x cubed. Okay. Let's look at the next one. It says using a constant multiple rule, find the derivative. So this is part C here. We're looking at part C here. So what can we do for this problem? Well, man, there's a lot that we could do for this problem. It's kind of up to you to see this. But here's what I'm looking at it as. I'm going to actually maybe multiply that 3 through. So this would be negative 9x. Multiply the negative 3 through again. Negative 3 times negative 2, which would be plus 6x squared. And then what I'm going to do is I'm going to divide each one of those terms by 7x. Why did I decide to do that? Well, the reason I decided to do it is because it is a single term in the denominator. And when it's a single term in the denominator, I like trying to separate and simplify. And let's see if that works well, because what I would have, well, the x's would simplify in this first one, and the x squared and the x would simplify in the second one. And in the first term, I'd have negative 9/7, and that's it. Plus, in the second one, I would have 6/7 x. That would be my original function. So to find the derivative, y prime would be significantly easier now. The derivative of negative 9/7 is just 0, and the derivative of 6/7 x would be 6/7 times the derivative of x, which is just 1. So I'm getting a derivative of 6/7. Okay. Put that in the answer blank real quick. And let's move on to D. D is 9 over 5x squared. Again, looks like the quotient. I could use the quotient rule, and the quotient rule would work with this. Low d high minus high d low over what's below squared, but it's easier than that. If you remember in the previous section, we would write this as 9/5, And then since x squared's in the denominator, if we wanted to bring it to the numerator, that would be x to the negative 2. So that's my original function. So if I want to find the derivative, it would be 9/5 times the derivative of x to the negative 2, which would be negative 2x to the negative 2 minus 1 is a negative 3. Cleaning that up, negative 2 times 9 is negative 18. On bottom, we would have a 5, and that x to the negative 3 we would move to the bottom, making it x cubed on the bottom. So our derivative would be negative 18 over 5x cubed.